let's first start by going over presentation. So what is C++? What is this crazy language that I've been talking about for the last 30 minutes? So C++ is a general purpose programming language, which is an extension of the C programming language. So if you guys kind of know your history of programming, C came before C++. And even before C, you had COBOL and Fortran, but you guys don't have to worry about that. All C++ is an object-oriented programming language, and it's used extensively. So if you guys later become programmers and computer scientists, it's great to start off with a C++ foundation, because there are a lot of other object-oriented languages that start using this. And if object-oriented sounds kind of confusing, don't worry. Again, we will be talking about that more soon, but just know that the thing that makes C++ kind of stand out from the rest, or stand out from other types of programming languages, is it is object-oriented. So object-oriented programming is a paradigm based on the concept of objects, whose procedures and codes can be accessed and modified on by other data fields of an object. So when you think about object-oriented programming, you can think about the fact that your code is going to basically create something. So it's not only creating an application or something that's going to be executed by your files. You can also create these instances of groups that are going to be modified and built upon by your C++ language as a whole. And so again, this will become much more sense when we talk about classes at the very end, on Friday. But just know that, again, the reason why C++ is so special is because it is object-oriented. So examples of other codes that are also object-oriented is Java and Python, those other two things that I said you can add to Replit, C#, JavaScript, Ruby, Perl, Swift, Dart, Kotlin, MATLAB. So if none of these sound familiar, again, that's okay. But the reason why we learn C++ basically is because it is the foundation that so many other languages are built upon, and that once you understand these concepts, it can be so much more easily translatable into tons of other languages that you guys can learn. So today, basically, we're going to be talking about compilers. So the compilers are the things that you guys basically just downloaded. So if you have MinGW itself is a compiler. If you downloaded Visual Studios, then Visual Studios includes a compiler. And if you had Replit, if you had that account, then that's an online compiler, basically. So computers understand only one language, and that language consists of zeros and ones. So if you guys have heard about binaries before, if you guys know that computers can only read things in zeros and ones, that's just basically being binary language. And so your computer doesn't understand anything else but those series of zeros and ones. And that series is called machine language. Now the problem as a programmer is you don't understand zeros and ones. We don't look at our world in a binary fashion. Even mathematics doesn't look at it in terms of binary. We actually go by a logarithmic base of 10. So if you know your tens tables, we always look at numbers in terms of tens and 100s, while computers always look at everything as a factor of 2, or to the power of 2. And so as humans, kind of programming a machine language is very difficult and cumbersome, and is often very confusing. So the reason why we have programming languages in the first place is to kind of bridge that gap between the language that the computers know and the languages that we know. So you can think of programming languages themselves as kind of as a translator, going in between and telling both us and the programmer, the computer, in a language that we both know. So programming language is the in-between. So to make programming, inspection, and understanding other programs even easier, we use high-level languages that are not machine languages. So again, machine languages are the bottom zeros and ones. High-level languages are C++, things that we can learn and understand, things that we can program the computer to follow our instructions. So again, C++ is one of those high-level languages. And because a computer can only understand machine language, humans only have high-level languages. So we use them as in between to be used as translations. So we use this, we're able to do this by using special programs called our compilers, interpreters, and assemblers that are built into our various application programs. So if you were to think of, for example, a programming language as an actual language, right? As either Spanish or English or Italian or whatever. And that's what allows us to communicate in between. The compilers, interpreters, and assemblers are the ones that actually string this programming language together and allows both the programmer and the computer to communicate with one another. So the reason why we have this MinGW, or the Visual Studios IDE, is because we can actually use those to basically translate what we need it to be done. So C++ is designed to be an actual compiled language so that it can be understood directly by the system, and it requires an actual developmental toolchain, which at its core is the compiler and the linker. So again, this is just like technical terms that basically mean you're translating code. This is code so the computer can understand us. And the tools that we use to create that code, the tools that we use to translate that code, is all the things that I've been asking you guys to download and all the things that we've been looking at for the last 10 minutes. So there's a difference though between compilers and console programs. So we can actually use text to communicate with the user and the environment as a whole, right? Because even if you look at the screen right now, like the Zoom screen, you can see like these words are all written in English, right? But actually behind it, you have all these compilers like computing a bunch of zeros and ones to make the text that you see right in front of your face. So these are called console programs. Basically anything that you're doing to get an input from the user, your input from a keyboard, and basically printing all that text out onto the screen. So these are console programs. An example that we just did was the text program. So if you remember when I did the first Hello World program when we were trying to do like through NinjaW, it wasn't actually a Hello World program, don't worry, but we opened up a text editor, and that text editor counts as a console program because usually you write words like normal English language, like notes to yourself, but then we saved it as a .c program to be used inside a compiler in the first place, to be compiled by that terminal that you saw pop up. So the way you compile console programs actually depends on the particular code you're using or the tool you're using. So I just basically showed you guys 3 different ways you can compile a program depending on like your level of comfortability or like what kind of operating systems you guys have or what kind of computers you guys have. And one of the easiest ways for beginners to compile C++ is usually by an IDE. So MinGW is not an integrated development environment because that uses a command prompt, that uses a command line. That little black box that showed up to you guys, that's what like old school programmers use. That's what like the professionals use. And that's the reason why like we tried to introduce you guys that in the beginning, just to at least see what it looks like. You don't have to use it 24/7. And in fact, a lot of people just start off by using an IDE, which has all of these tools kind of presented to you in a very nice and easy fashion that's more understandable even for us humans. And it provides like a graphical user interface, which is called a GUI, but basically makes it so that you can understand what's in front of you. So again, IDE integrates several development tools together, including a text editor and tools to compile programs directly with it. So what I am going to ask you guys to do is I'll be giving different instructions for different people, basically, depending on what kind of compiler you have. But this is basically what you're going to be writing down. So for now, all I want you to do is write this word for word, line for line, into a text editor if you have MinGW. So if you have a Windows computer, all you have to do is go into your search bar and search text editor, and that will show up for you. And once that shows up, then you basically just have to copy the exact same thing I did here, like this part here. And that's just going to be your first program. Once you're good with that, either put your thumbs up or just let me know.